Hey, what's going on, guys? Today we're going to go over the RC car that I've designed, 3D printed and assembled, and some of the things that we're working on and where it's going to go in the future. So stay tuned for future videos and let's get into it. So here is the car. It's actually a short course truck. It's a 10 scale short course truck designed off the Roar racing rules. It's roughly about, fully loaded, it's about 5 pounds, 5.5 pounds. Right now it's about 3 pounds. The electronics I have in it, it's a tack-on, the motor is a brushless tack-on 3500 kV, 36 millimeter cam motor, capable of 3S, the 120 amp ESC from Hobby King, and a servo from Hobby King, 620 AMG. I have a Radio Link RC3S receiver, and that's the electronics. The car is the majority of it is 3D printed. Things that are not 3D printed are the bearings and the screws, electronics, the pins for the axles. Those are just old nails I had laying around. Pins for the suspension, again, nails I had laying around, and the wheels and tires. You can 3D print these. I just decided not to. And then the hubs, they're actually 17 millimeter hubs. Even though this is a 10 scale truck, 17 millimeter hubs are meant for 8 scale cars, and I'm using those to give me a little more room for the drive shafts, or the axles, so that I can have more material for the axles. Other than that, the other things that are not printed are the front and rear differential gears, ring and pinion and differential gears. Those, I got a plan in the future to make those 3D printed. So that will have to be in another version of the car. So for right now, I'm just trying to get those up and running. And let's go into what we are experiencing for issues. So number one, this failure was not due to design. It was basically just a bad setup. So I did not have the mesh set correctly, and I stripped these gears out. The other problem I had that I did resolve was this pinion would strip out. I did have this printed in PLA, and there's a PLA interior, and then I had the ring gear would be this nylon bridge material, and that failed because the PLA would heat up when the motor would heat up and would distort, and I would fail the pinion. So I made it out of nylon, which this has lasted. Well, the first part I made lasted maybe a couple minutes of just bashing on it, and then it stripped out. I just didn't have the clearance set right on the profile of the shaft, and another thing was the screw was not tightened all the way. So I used some Loctite, made the clearance a little tighter, and I haven't had a problem with it. So yeah, we're working on the gears right now. This is a slipper clutch design, so it's an adjustable mesh for the motor plate, and then this is the slipper clutch spur gear. So the spur gear, you see, has the hole in the center. That rides on the same material bushing, made out of nylon as well. So it's nylon on nylon, and the slipper material, or the clutch material, would be this gasket. That would be on either side of the clutch. And then basically the clutch is made up, you have the slipper shaft, and the whole assembly is compressed by a printed 3/8 nut. And then there would be a slipper clutch plate on either side, so it would be a double clutch, we would call that. Twin disc clutch, if you want to say that. So that has been working pretty good. Once I got the nut, I did have a steel nut on there, and then I put the nylon nut on, and the issues of it loosening up went away. So that's been working pretty good.
Some other parts I have for it. This is a 4-wheel drive. Obviously, we got the front and rear differentials. So this is the center drive shaft. I haven't had any problems with this. The battery holders, front and rear battery mounts, actually integrated a drive shaft support. You can see there. So the drive shaft sits right in there. And the reason I did that was at higher speeds. You know, we got this thing, the motor spins at about 30,000 RPM. So this guy's spinning roughly half of that, so 14,000 RPM. And what'll happen is since this is made out of nylon, you start to get into vibration and unbalance, or just you'll run into a resonance issue. So I have an extra support in the middle for that. Leading into that, talking more about the slipper clutch, I did have a PLA slipper clutch shaft, which actually worked great. And then I was tightening the nut for the slipper clutch and snapped it right off. So then I went to this nylon material, and it's working good. But since it's a less stiff material, you know, at 14,000 RPMs, this thing starts whipping around and starts causing a lot of issues. So I made this support that I'm just going to drill another hole in the chassis. And this is a temporary fix, but you know, it's going to hopefully solve our issue with that vibration. But we'll have another bearing right there, and hopefully that holds it together. I may need to adjust the design of that coupling, but that's what will be coming next in the next design. For the slipper clutch, we have this it's a wider. I made this probably about twice as wide. So hopefully that will not strip as easily, and making it wider also changes the dimension of the slipper pads. So I'm going to have to cut those down in order to fit inside of the pocket for those. And so that's the basic assembly of the center powerhouse, gearbox, and driveline. The driveline, you can see the axles are 3D printed. Those are one of the things that get the most load with the gear reduction, and that's one thing I always look out for to break. So the noise of the car, I got the front and rear differentials in. You can see it doesn't make much noise at all. All you hear is the metal gears on each other. Once you get the plastic gears in here, it makes a little bit more noise. But once you put some load on it and spin it up, the gears actually, I feel like they break themselves in, and the noise starts to go away, and it starts to sound like if they are metal gears. So pertaining to the gears that we're printing, that we're going to try out, let's take a look in the printer right now. So we got two different styles of gears, same type. The only thing I changed was the module and the gear count. So it's the same diameter. One gear is the original gear count, which is 38 teeth. The other gear is 30 teeth to create a bigger, a wider tooth. Because I was having issues with this material printing the spur gears that it did not have with the nylon bridge material. That stuff worked pretty well printing gears out. Why am I not using the nylon? Because I'm just trying to use this trimmer line material as often as I can, because it is a cheaper material. But yeah, anyway, you got those two styles, and then we also have the pinions for those as well. All right. So that's what we have going in the printer.
All right, guys, that's going to do it for this video. I want to thank you for watching. If you liked it, be sure to hit the like and subscribe button. Stay tuned for future videos as we dive into progressing this car forward. Thanks.